Welcome to Section 5.8, Part 1. This is the 60-second session of the ISACA CISA exam prep series. In this session, we'll cover virtualization and virtual networking. We'll answer several questions. What is virtualization and what risks does it bring? How do you secure the hypervisor? What are virtual circuits, networks, and storage? What is software-defined networking? And how does containerization differ from full virtualization? Why does this matter beyond the exam? Because almost every modern data center runs on virtualization. Picture a company running 50 servers on a handful of physical machines. That efficiency is wonderful, but it concentrates risk. Break one host, and you could reach every system on it. As an auditor, you make sure that concentration doesn't become a catastrophe. Let's start with the core idea. What is virtualization? It lets multiple operating systems run on one physical server, isolated from each other. A layer sits between the hardware and those guest systems to share resources. The key piece is the hypervisor. The physical machine is the host. The systems running on it are the guests. You can deploy it two ways. Bare metal runs the hypervisor directly on the hardware. Hosted runs it on top of an existing operating system. Virtualization brings real benefits, but also real risks. What's the upside? Lower hardware costs, a smaller footprint, and easy duplication for continuity. What's the danger? The host becomes a single point of failure. Attack the host, and you affect every guest on it. One guest can bleed data into another when memory isn't cleared. And a compromised management console hands over the whole system. So how do you secure a virtualized environment? By treating virtual components like physical ones. Harden the hypervisor and guest images to industry standards. Protect management traffic on a dedicated network and encrypt it. Patch the hypervisor as fixes arrive. Disable services you don't need, like file sharing between guests. And here's a point people forget. Patching the host does not patch the guests. You must update each virtual machine individually. Now let's add virtual networking. What is a virtual circuit? It's a logical path over a packet switch network linking two endpoints. A permanent virtual circuit is always available, like a dedicated line. A switched virtual circuit is created on demand and torn down after. The switched one is more secure because it's exposed for less time. What is a virtual local area network? It segments a network logically without changing the physical wiring. Switches create it. A static one assigns ports transparently. A dynamic one negotiates membership. It controls traffic, isolates segments, and reduces exposure to sniffers. Just remember, a virtual network is not the same as a subnet. What about virtual storage? A virtual storage area network is a logical partition for virtual machines. It isolates storage traffic, so a problem in one area causes minimal disruption. Its benefits are cost savings, scalability, and simplicity, since it uses existing hardware. Compared to a traditional storage network, it needs no dedicated hardware or separate network. Now a major shift in how networks are run. What is software-defined networking? It controls the network through software rather than device-by-device configuration. Traditional networks lock you into hardware. This approach lets you provision resources virtually from one place. It separates into three planes. The data plane forwards the actual traffic. The control plane decides the paths and is where the administrator works. The management plane handles configuration and monitoring. A wide area version connects distributed locations and is managed by vendors. What does software-defined networking give and cost? The advantages are strong. Centralized control, easier scalability, lower operating costs, and a clear security viewpoint. But there are downsides. Latency from all that virtualization. You can manage the services, but not always the devices themselves. And the controller is a critical dependency. If it fails, the whole network can go down. So watch for attacks on it. Things like denial of service against the controller, or man-in-the-middle data changes. Best practices include deprovisioning unused resources and combining it with other security tools. And always remember, it's a form of virtualization, not a security solution by itself. Finally, a lightweight alternative. What is containerization? It runs one operating system but isolates applications into separate spaces. Instead of a full operating system per virtual machine, containers share the hosts. Each container bundles an application with everything it needs to run. The benefits are speed, portability, and efficiency. But there's a catch worth knowing. Containers share the same kernel. So if an attacker compromises the host, every container is at risk. Best practices include hardening, continuous auditing, and securing the images that build containers. So let's bring it together. Virtualization runs many systems on one host, which concentrates risk. The hypervisor needs hardening, and guests must be patched individually. Virtual circuits, networks, and storage isolate and segment logically. Software-defined networking centralizes control, but leans on the controller. And containers are lightweight, but share a kernel, so the host is critical. Master these, and the cloud built on top of them will make sense. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.